Hi guys, in this video we will discuss about const pointers in C++ and how it is different from a pointer to const value. Then we will see what is a const pointer pointing to a const value. Let's start our video. So what is a pointer? A pointer is a variable which stores an address of another variable. Like here, num is an integer variable which contains the value 11. Then we access the address of this variable, address of the memory location where this variable contains the value 11. Now we initialize our pointer with this address. Now our pointer ptr is pointing to the memory location where the value 11 is stored. Now we can change the value to 22. If someone tries to print the value num again, it should have value 22. We can confirm this by running this code. The value of variable num is 22 now because we access the value using the pointer pointing to the address location of this variable num and change the value to 22. So this is how we can change the value at a memory location using the pointer pointing to that memory location. But many times this is not the requirement. Now suppose we have a function get square. It accepts an integer pointer as an argument and returns the square of the value at the memory location pointed by this pointer. So we can do that like this. This is the value where this pointer ptr is pointing. Now this expression will give us the value at the memory location where this pointer ptr is pointing. So we will multiply it with itself. So like this. So this function will give us the square of the value at the memory location to which pointer ptr is pointing. Now let's call this function and say int square is equal to get square. Here we are passing num. Here we will create a pointer and initialize it with the address of variable num. And in the get square function we will pass this ptr. So here we have declared a variable num and then we initialize a pointer ptr pointing to the address of this variable, and then in the get square function we pass this integer pointer. It will return a square of the value at this memory location. Now if you run this code, so it should print 121. That is the square of value 11. Now suppose a new developer comes and he decides to make certain changes in this function like this. Ptr is 2. Now inside the function he changed the value in the memory location pointed by the ptr to 2. So this function will return 4 and the value which we will get as square will become 4. Also if you try to print the value num here, that will also be changed. It will become 2. If we clear the console and print it, so you can see the square is 4 and the value of num is 2. This was not the expected behavior of get square function, but someone changed the value at that memory location because we provided him a pointer pointing to that memory location. Now what if you want to restrict so that the developer who is implementing this function cannot change the value at their memory location? For that we can do like this, const. So here we are saying that pointer ptr is a pointer pointing to a const value, so it cannot change the value. So here as soon as we added const here, so we can see we got an error. It's saying that we cannot change the value here. Even if you try to compile the code, it will give error at the compile time. See, that value cannot be changed at that memory location. So this is pointer to a const. So it will not allow the value to be changed at that memory location where pointer ptr is pointing. But what if someone tries to change the value like here and make the pointer ptr point to a new memory location like this, say 100? In that case value of num will not change, but still it will return the wrong value for the square because inside the function we made the pointer to point to a new memory location. Pointer ptr is pointing to a const value. We cannot change the value, but we can make the pointer ptr point to a new value. So if you want to restrict that, you can remove the const from here and assign the const here. So now we are saying that ptr is a const value. We cannot change the variable ptr. We cannot make the pointer ptr to point to another memory location. So here we can see it's giving an error at the compile time. We can confirm this. So it says that pointer ptr cannot point to a new memory location. So when we want both the functionalities, so we can do like this, const integer. So here we are saying that pointer ptr is a const pointer which is pointing to a const value. So neither the value at that memory location can be changed nor ptr can point to any other location. So if someone tries to change the pointer, and make it point to a new memory location, it will be a compile time error. Similarly, if someone tries to change the value at that memory location, it will also be a compile time error. So in this video we discussed about three things. First is const pointer. A const pointer means that the memory location that the pointer is pointing to can be changed, but the pointer itself cannot be changed and point to a different memory location. In other words, pointer is constant, but the data at which it points is not. Second is pointer to const. A pointer to const means that the pointer can point to different locations, but the data at that memory location the pointer is pointing to cannot be changed using the pointer. In other words, data is constant, but the pointer is not. We can make the pointer point to a different location. The third one is const pointer to const value. Const pointer to const value combines both the concept of const pointer and pointer to const. Now pointer cannot point to a different memory location, and data at the memory location cannot be changed using the pointer. So both the pointer and data it points to are constant in this case. So in this video we learned about const pointers, pointer to const, and const pointer to const value in C++. This video is a part of pointers course in C and C++. For more videos related to this course, you can check out our playlist on YouTube, or you can go to our website thispointer.com for the complete course. Thanks for watching. Don't forget to like the video and subscribe to our channel.